Good morning, Oliver. I'm
Good morning.
Laurent from Microfocus. Nice to have you in the session. Uh, Oliver is the CTO of IT Networks and is going to be talking about their e-voting platform, Devo, and how they're protecting customers' data with voltage secure data. So your turn, Oliver. So what are you exactly doing with Devo? Well, what is Devo?
Hello. First of all, thank you for having me on Microfocus Universe. Um, at IT Networks, we develop software for secure, auditable decision making. Software is called Devo, what means digital voting. You can
Okay.
reach out to us on digital-voting.com. The software could be generally used in any digital decision making process, general assemblies, or for approvals or digital signatures. We use the software a lot in general assemblies, fully digital or hybrid, where the participants vote by a smartphone or in front of their computer. The software can be used also for public voting, where it's very important to protect the anonymity of the voters.
Mm-hmm.
And yeah,
And maybe a question: How is blockchain? How is it important? How is Devo connected e-voting to the blockchain? How is it relevant to blockchain?
The DEO platform is built on the most recent technologies, and we can guarantee the user identification and authentication on the highest possible levels. Beside the blockchain, where we have the audit-proof store of any kind of voting or decision making, we have also several options from identifying a user by his ID or passport. We have enhanced two-factor login for signature approvals by biometric face recognition, so we can 100% identify a participant. And blockchain we are using wherever a tamper-proof audit trail is necessary to store data such as decisions and signatures in a tamper-proof environment. We are using here public blockchain, so we have the most possible distribution of data and in a secure environment. And optionally, it can work also with private or permissioned blockchains.
Okay, and so how does Microfocus voltage secure data help you with Devo, with your voting platform?
We discovered on the market to find a solution that helps us to protect the user's privacy. With the use of voltage encryption appliance, we are able to protect the user's privacy and secure data that is then stored or written to a blockchain. This is very important, for example, in public votings, where users must remain anonymous, or where we are using one-way hash functions with some user data to secure the user votings and decisions, and only allow votes for authenticated users which are associated with this hashed function from voltage.
Okay, and okay, this is very interesting. Is there a way that you maybe could show me? That I'm a visual guy, so it would be interesting to see it in form of a short demo. Is that possible?
Yeah, we can have a quick look into it.
Fantastic.
Let me share my screen.
Oh.
So we have here our identity service. Here we see the several two-factor authentication mechanisms we have. This is SMS, Google Authenticator with the QR codes, or here our biometric face recognition.
Yeah.
I have to stop the camera quickly. Looks like my camera is blocked from. Let me take SMS 1 second.
Okay, sure. That probably makes sense because it's locked into the session.
Yes, correct. Now I switch here to English. We have several languages available.
Okay.
And here on the dashboard, I see all my authentication and identification steps I made already. It's my profile. We're checking here the user's identity by his passport or profile, like KYC you're doing with the bank. And then we have SMS registration, two-factor authentication with Google, and the biometrics for the face recognition. Let's go straight into the module e-voting. E-voting can be used for public votings, for private votings. Whenever you have a proposal to vote over, or within a company for management decisions, stuff like that. Here we have an example of a public voting ballot. On the right, you see we identify the user by his social insurance number. We take that social insurance number with a one-way hash function with voltage that creates as a format preserved anonymous number. This number will then be registered on the blockchain that this user is allowed to participate in this voting.
Okay.
We can guarantee that there is only one vote per person, or even allow only a group of persons to elect or vote in an election. And this will create a QR code also that you can theoretically print on the voting ballot that the user receives on paper for digital voting. And then once you send up a vote, we write that to the blockchain. We have here a transaction ID, the block ID, the timestamp of the voting, and here is the encrypted data. We write on the blockchain the anonymized social insurance number and the data that you voted for. So this will be fully encrypted on the blockchain. It can be decrypted by the company running the voting, and the user remains anonymous because we have a one-way hash function of the social insurance number.
Okay.
And then, for example, for general assemblies, we have a security register. In this demo, this is an association. So we can here distribute the voting power. That could be also shares in a company. We can delegate voting power, we can transfer the shares, and we have some overview of the owners, and of course the history where they are issued or transferred to users. And this is also written on the blockchain. And yeah, we use this registry for votings in companies or associations. Just do a quick demo here. We have General Assembly. Here the user also has to
confirm his presence in the meeting.
Yeah. See, yeah, now it works. No, it doesn't work.
So just a question. So essentially with voltage, could we say that well, customer data, user data, or user name, or social insurance number would be made GDPR compliant in this sense?
Yes, correct. As we don't write directly personal data on a blockchain, we are fully compliant with GDPR. And if a user requests to delete his data, we delete the pointers in the database, and then the encrypted data is no more accessible.
Okay, that's a very Very interesting use case. Well, well, thank you very much, Oliver. This was very interesting on that topic. So maybe also a question. So on the use case, and in this case, it's for internal votings, internal elections in an organization, in a company. Could it be also for public voting? Is that to envisage? Is this something you're looking at in the future?
Yeah, public votings, they will have still some challenge on legal side, data privacy.
Yeah.
But from a technological perspective, we have seen in the demo that it is possible. There are several projects and researches going on in this space. And on the other hand, for digital corporate governance, it's widely used and adopted. And it will be used for as we have seen in general assemblies, or also for digital decision making, management level, or for proposal, purchase orders, approvals, stuff like that.
Yeah, that's a very good use case as well. So we essentially have multiple use cases, which is pretty good. So Voltage can add the value to anonymize or pseudonymize the actual data, which is great. So potentially could envisage during the usefulness of the data, or while you use the data, let's say while a process is pending or still active, or a election is ongoing, the data could be encrypted, and at the end of its life cycle, it could essentially be hashed, right? So that could be a possibility. Just, for GDPR compliance purposes, that data is not recoverable, or partial data is not recoverable, just to be compliant. That should be also possible, I guess.
Yeah, but that was the main point we are using Voltage. First of all, we can encrypt the data. And on the other hand, we have the possibility for one-way hash functions. So we can fully anonymize data. Mm-hmm. And on the other hand, we have two-way hash function where we can also read data on a corporate level, for example.
So the interesting thing is also we have seen in many countries, if we're looking at Germany, Switzerland, Liechtenstein, famous one. There are lots of companies in the blockchain space. I have followed that, and I'm seeing a lot of adoption also in the government space of public blockchain. So public permissioned, public unpermissioned, and then private permissioned blockchains. Obviously, it depends. Again, it's all use case based. So could this be applicable to multiple type of blockchains, like, for example, Hyperledger, Corda, or EOS, or Ethereum, for example?
Mm-hmm. Yeah, of course. Our solution is built modular, so we can connect theoretically to any kind of blockchain technology. Currently, we are running on the EOS.io network because they have very advanced smart contract functionalities.
Yeah.
And if a company wants its own private or permission-based blockchain, we can also connect to such a system. That's not a big issue.
Fantastic. So Voltage essentially could add value in different blockchain environments. So that's quite good, and render essentially data compliant during its life cycle. So that's wonderful.
And we're also planning to using Voltage as a cloud service where we can just send data out, we anonymize it and publish it on a blockchain of your decision, and you get the transactions back, transaction ID, block ID you can store within your database, and always explore the results written to a blockchain.
Okay. Because for example, you wouldn't write a name like John Smith, or in Germany maybe Peter Muster. You wouldn't write it as a plain name to the blockchain. I guess you would write a user ID or a synonym essentially to the blockchain, which would reference back to the actual user, right?
Yes, correct. Because any data written to a blockchain remains there forever.
Yeah.
from GDPR policy and other data policies around the globe. You don't want this personal data stored somewhere where you're no more able to delete it. So that's why we're using voltage from Micro Focus to fully anonymize data.
Yeah, which makes sense, because we had this discussion, and I followed also the quantum computing space. There is no risk yet that a quantum computer can reverse a one-way hash function, or decrypt or break any algorithms, encryption algorithms. At this stage, AES is quite safe, but you never know. At the end of the day, it's not. There's not a large adoption yet. I mean, Google, IBM are very well known for quantum computing, but there are not that many out there yet that we have to worry too much about that. Maybe in the future, in 10 or in 20 years, who knows? So wonderful. Thank you very, very much, Oliver. It was great to hear about your project and how you're protecting your customers' data with Micro Focus voltage secure data. So looking forward to meeting up sometime. Thank you.
Thank you for having me, and I wish everybody successful day on Micro Focus Universe.
Thank you.